Well, thank you very much. Welcome, everybody. It's good to be back at JDD a year later after I was in this room. First talk of the day, last time around. Martin and I want to talk about a subject that is near and dear to our heart because we do believe that as the development community, we've kind of nailed this whole agile thing for software and the code, but we still struggle pretty badly when it comes to databases. And unfortunately, most of the applications that we work on, databases are effective life, and knowing how to evolve them quickly and effectively becomes an important thing if you want to continue to evolve your architecture. By the end of the talk, we hopefully will be able to tell you a bit about the theory of database refactoring, as well as some of the things we're doing, and Martin and I put together on the product we used to work on together that allowed us to rapidly and effectively push the database and database changes to the tune of hundreds of thousands a night of individual changes to the production environment and still be able to sleep at night.
Sometimes.
By the way, before we get through this, we have a legal team working for Oracle, has its advantages and disadvantages. They're pretty big, so they made us put this. So those opinions are Martin's and I, and do not officially reflect the opinion of the corporation.
Hi, guys. So the content for the presentation is going to be broken up roughly in two parts. First, we'll introduce ourselves, and we'll tell you why we think we can actually talk about the topic. The second part, we'll jump into the fundamentals of database refactoring. This is going to be a little bit of a dry theory, but we're not going to spend much time on it in this particular version of this presentation, which is shortened. And then eventually we'll get into putting it all together, which is a case study during which we'll show you how we've applied the theory in practice, and we'll be very, very specific. We'll give you some interesting pointers, some solutions that we've came up with, and hopefully this will inspire you to maybe do the same in your products and code lines. And then we'll wrap up with a Q&A, time permitting. So let's start by introducing ourselves. Leonid is a Java developer, has always been a Java developer since I've known him for 12 years or so. He's based out of California. He's got 15 years of SaaS experience. He was doing SaaS before SaaS was called SaaS.
Yeah, when it wasn't as cool to call it SaaS, we used to call it ASP, Application Service Provider.
And he's an avid traveler, loves Krakow. This is his 5th or 6th visit here. And usually, he also does take good pictures. I'm actually surprised that he doesn't have his camera with him on stage to take pictures of you, but probably an iPhone in a pocket that he might pull out later on.
And Martin is now based in Poland. By the way, the reason we're doing this in English, it's not because I cannot speak Polish. It's because Martin's professional Polish doesn't exist. He did spend a lot of time in North America. Him and I will work together for a while on similar products. Again, Martin's been SaaS for a very long time. And one important thing to know about Martin when it comes to the process we'll be talking about is he's not a big fan of SQL. A lot of people, there's very, very modern thing to do to talk about domain-specific languages, and quite often we forget that the most modern domain-specific language in the world, sorry, the most popular, not the most modern, the oldest, is SQL. Martin also travels. We have some pictures from his own travels in this presentation as well.
All right, so now that you know who we are, we'd like to find out who's in the audience, because we may have to tailor the content of this presentation a little bit, and we'll tell you why in a second after we find out who's in the audience. So, who's a developer here? All right.
Good size.
The important question now. Are there any DBAs in the audience?
3.
1, 2, 3. Okay,
so we'll have to tailor some of the jokes, man.
Damn it!
All right.
I was hoping for all developers crowd.
We'll be gentle.
We'll try. Any people who like to write complex SQL? The DBAs, of course, but
no, actually, not every single
some
DBA.
Other nutcases
exactly,
there, right?
That's kind of strange. Not
Good.
every DBA that raised their hand raised the complex SQL thing. Interesting.
Scary. Who here maintains their own schema and writes their own scripts to change that schema?
About 20%, lower than normal, huh?
Lower than normal. And does anybody use a tool for that, like Play or Roo or something equivalent?
Again, lower than normal, man.
Very interested in your experiences.
Or success,
yeah,
if any.
All right.
So, Database refactoring. The good thing about database refactoring is that the fundamentals have been known for a while and have been actually pretty well documented. We don't have a lot of time today to talk about all of the stuff that is known and is available, but there's an amazing book, and if you're interested in the subject, highly recommended. The book is called Database Refactoring, the Refactoring Database. It's from Martin Fowler's Signature Series. Excellent subject, and like the original source refactoring book, it does a really, really good job explaining step by step all the concepts and all the refactoring types that we'll be mentioning here. We'll do one example just to demonstrate the typical steps that you see in some of the considerations you would go through, but I highly recommend getting this book. It's an amazing content. Now, when we think about refactoring, you know, we as a human race have been refactoring things for many, many years. This is a picture from a recent trip of mine to Guatemala. This is a Mayan temple. Just for size reference, if you can see in the lower left corner, there's like a human being or two. This thing is about 50 meters tall, was built before any modern technology existed, but a lot of Mayan temples start very small. It starts like a small temple, and then every Baktun, which is I think 12 or 13 years, I can never remember, they build an extra layer and expand it up and outwards, right? To me, it sounds quite frequently and very similar to some of the software systems that I've worked on, right? They all start small, and then over time, they expand upwards and outwards with all kinds of... by the way, this thing is full of empty chambers inside that you cannot access anymore. Sounds familiar?
Yeah.
Yeah. So we're very, very familiar as a human race with refactoring, right? We're also very familiar with patterns of software refactoring. Not a new concept as well. The famous Martin Fowler book on refactoring, I guess for me the gold standard of how to do refactoring properly. But even when Martin was writing that book, he has noticed one thing, right? Databases are still very, very difficult. And unfortunately, the problems of refactoring databases are not technical quite often. Lack of tooling or lack of good tooling is a challenge. And as it was very clear here, not a lot of people using tools. We all, a lot of time do this by hand. But the divide, and in all seriousness, we joke about the DBAs, but the divide between the software team and the artifacts that they own and the database administration team and the artifacts they own does not help.
Right. Part of the reason why it's hard to refactor databases is that there are many stakeholders in that process. When you're touching code, you're mostly, you're pretty much, as a developer, you're the only stakeholder. If you do your refactoring right, nobody will know. You've done a good job. With databases, there's other people other than you who are interested in the database. So, well, of course you are interested, the developers, but there's also, DBAs whose role is to make sure that the database runs smoothly, that there is enough space, that indexes are in order, that everything is nice and dandy. And if you start refactoring a database and making changes, they will need to know, and more likely than not, they will also want to have a say in what you're going to do. Another group which I came across that is very common as stakeholder in databases is QA departments. Oftentimes they rely on the database state. They run some scripts to populate the database or to validate certain things against the database. So if you refactor it, if you remove a column from a certain table, they might be pretty upset that you've done it without informing them or getting their buy-in. And there's another group that's commonly using the database, that's business analysts. These folks are probably running some very complex reports, and refactoring a database will affect them. So any changes that you need to do, you will have to run through this group of people to get their buy-in, and that might be hard. Like this is probably extra work that you're going to introduce to all these folks.
But knowing how to do this creates a lot of benefits, right? Designing data models up front is hard as it is, but designing data models up front at times just impossible, right? Most of us probably work on applications that power the business, and the nature of those applications is quite often they're long-lived and they evolve as businesses evolve, right? Companies expand into new fields, etc. So quite often designing a new database model up front is just absolutely impossible, right? So knowing how to do that effectively and efficiently, much like we all learned with code, is extremely beneficial to us. Also, some of us inherit database schema designs from other teams or previous generations of software engineers that worked on the product. And knowing how to get rid of database smells, like you can get rid of code smells, also helps. And if you think about, database smells, some of the common stuff we see in databases we've run around, things like redundant data, too many columns in the table, fear of change, the psychological stuff, multi-purpose columns. In some cases, they're okay. Like even like some of our applications are heavily metadata driven, and we do reuse columns when we know. But I've seen databases where sometimes the column will have a phone number, sometimes it's a zip code. Go figure what's inside. So knowing how to get rid of this is also extremely important.
All right, so having covered some fundamentals, let's get into more specifics on the mechanics of database refactoring. Let's start by defining what a refactoring in terms of the database really is. And we like this definition that says it's a simple change to a database that improves the design but does not change the behavioral and informational semantics. A key ingredient of this definition for me is the simple change. You want to make those as atomic and as simple as possible for a number of reasons. I'll just give you 2 or 3. First of all, the simpler the change you make, the easier it'll be to apply it to a database, and it'll be also much easier to roll it back should you screw up, and you will screw up because you're human. So sometimes you make a mistake. If you have small incremental changes, it's much, much easier to apply and roll them back. It's also much easier to review them and to be able to quickly see what they do. This is a typical divide and conquer approach, which is great for databases as well. We do the same with code. And the way you're going to go about applying these changes will greatly depend on the application architecture type that you're dealing with. There are roughly two types. So who here has kind of this scenario? You have an application and a database, right?
So by the raise of hand, just one app, one database.
One app, one database.
Yeah, like we expect, about 10% of the people.
Yeah.
Lucky you.
Lucky you. Your refactoring techniques and approach are much easier. Now, I think more commonly, we kind of come across this scenario. You have a database and an application that's yours, that you know you're running against this database. You may have another application that you know of that's running against the same database. And you may have an application that you don't know of that's running against your database.
Somebody decided it's okay to share the database. They just gave them the username, password, and they're using it.
Not uncommon. I've seen it. Plus, you can have a number of other integration points, test scripts, some test code, other databases. If you have that, you're really screwed. BI tools, a whole bunch of other integration points, which mean that, if you're in this scenario, which probably most of you are, your refactoring is much harder because A, number of stakeholder increases, B, the complexity of what you need to do also increases.
So when you think about the key steps that you would need to take in those scenarios, which are the scenarios most of us live in, really it all starts with the agreement. You have to get all the stakeholders together and decide that, yes, we do need to change the database, and here's what the change is. Obviously, you have to apply the normal steps and refactor the schema. More on that later. Sometimes when you're refactoring databases, you have to move data around, which is probably the most dangerous thing you're going to do with refactoring databases. We do that with live customer data in production. Customers get really, 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 really upset when we fuck it up.
They like their data. I don't know.
Those customers. Refactoring external access program obviously is important, especially when there's more than one. Running your tests. Yeah, that's a tricky one. Martin and I are speaking at another conference later this week where there's a talk on TDD for the database, but I'm curious, who here has a test harness just for their database? Anybody? One. Oh, wow. That's a first, actually. Typically, there's zero. Hired. Let's talk after the talk. So quite often, you end up running some other tests that exercise the database to make sure that you didn't break it, right? Or didn't change the informational semantics, whether it's your application regression test, some unit tests, some UI tests, and at times some manual tests, right? Version control you change. Could not emphasize it more. We have seen so many organizations where code and SQL artifacts don't coexist. Code lives in source control. People understand how to branch it, how to manage it, how to review it. And then there's other stuff, files over there, SQL. Yeah, we don't touch it. It's scary, right? You have to apply version control if you want to be effective at refactoring databases. Obviously, announcing the change to the broader audience that cares about the change is important. Deploying this to production. And since you are refactoring databases, which means for a while the schema may have to maintain two semantics, the old semantic and the new semantic, you eventually have to deprecate the old schema and remove some of the kind of scaffolding code you put together in order to support that.
All right, so now that we know what we mean by database refactoring, let's talk about what kinds of refactorings are there. They roughly fall into 4 categories. First one, probably most commonly done, are the structural refactorings. As the name implies, these are modifications that change the table structure. Most likely, for example, moving a column from table to a table, right? The second category are data quality refactorings. These are things that you're doing to your existing data to improve its quality. A quick example could be formatting a phone number in a column, right? You might have it as a number or a string. You now want this to be of particular format. You apply some sort of data quality refactoring to achieve that. Third common category is referential integrity. These are all the refactorings that you would perform to ensure that the reference rows actually exist in another table, or anything. In fact, this is anything that has to do with referential integrity. I've seen databases that had none of this initially, and with time we added stuff on as needed. Now, it's a religious discussion whether referential integrity should be completely enforced at the database level or not. Probably a separate topic, but we have stories about it too.
We do.
So if you want to hear them, maybe afterwards. The next category of refactoring is functional. This is anything that you do to your stored procedures and functions, and also possibly triggers, should you be that lucky to have any.
Another religious debate, right?
Yep.
Triggers and stored procedures, are they good or are they evil?
And then last but not least are the non-refactoring refactorings that are changes that do change the database semantics. So adding a new column to an existing table would be an example of that. All of these are very well described and categorized with beautiful examples in the book that Leonid has mentioned. And we only have time to cover some. So we'll very briefly give you a list of structural refactorings. Most common stuff is replacing column, dropping column, renaming, and so forth. But there's really a lot of them, and they're all very useful. So let's jump into one example, and that's the only one we're going to cover today in terms of the dry theory. So we're going to talk about renaming a column. How do you go about renaming a column? Well, we'll give you a pattern that will apply to all of them, really. First thing you need to do if you want to perform a refactoring, code or database, is ask yourself, why do I want to do it? What's my motivation for doing this? In case of renaming a column, we can think of two things. First of all, you're trying to improve the readability of your schema, right? I've seen databases where column names were XYZ, right? It's fine if you have 3 tables. Once you have 30 tables and names like this, you're just going to go insane. You're not going to know what's going on.
Nothing like reading a schema that says field 5 at 2 in the morning.
Yeah.
Love that.
So that's one of the motivations. You may want to improve the readability of the schema. The second thing you might be trying to do is move off to a different database where the column name that you used in another database is a restricted keyword.
Oracle.
Yeah. For obvious reasons, you need to rename that. So once you establish your motivation, you also have to ask yourself, well, what's the cost? What's going to happen if I do it, right? What are the trade-offs? And in this particular case, the trade-off is your readability versus what you have to do in the application to make that change. If you're using ORM and you're changing a column name, then you're probably changing one mapping file, right? However, if you're using straight JDBC, you might be affecting 200 classes, God knows, right? On top of that, you might be affecting all the other applications that are using the same database, if there are any. So, let's say that you're okay with the trade-offs. Well, then you move into update mechanics. What do I need to do to actually rename the column? And this gets a little tricky here. So, first thing you do, according to this pattern, is introduce a new column. Pretty simple. This is a new column with a new name, right? Now, the second thing you want to do is you want to add a trigger, and as much as we hate triggers, this is one place where they really do what they should be doing and what they were designed for, I think. Did you want to say something about your hatred of triggers? Yeah, okay. So what this trigger does is it basically synchronizes the data between your old column and the column that you've added. And it'll become a little more clear in the next slide. I have basically a diagram. And then you may also want to consider renaming all the referencing columns, so for sanity, when you're looking at stuff in the database, you know what's referring to what. And finally, you gotta think about a data migration. So in this particular case, you obviously have to migrate the data from the old column to a new column. And data migration is a topic that's also very well covered in the book we showed you. There's a ton of data migration patterns. There's quite a few of them, and they're all very useful as well, even if you're not doing refactoring, just for data migration, basically. So here's a more concrete example of that refactoring. So we have a table that has a customer ID. It's a customer table, has a customer ID and somewhat poorly named column F name. Stands for first name, but you know we're trying to improve the readability of these.
Amen. Typing is hard. Extra characters, you know.
5 a.m. morning, whatever example. Right?
Yeah.
I want to be able to just read it and not think whether it's my first name or some other F name. So what we're doing here is we're basically following the pattern, right? So we're adding a first name as a new column, and we're also adding a trigger. This is what's known as a transition period. So there's going to be a transition period of time when this database will have two columns that are synchronized on update, insert, or drop, so that all the other applications that are still relying on the old schema and having the F name are still working correctly, right? After a transition period, you would normally announce that to all the stakeholders, agree upon a date, and after the transition period, the simple thing is to just drop the F name, and then you just remain with a nicely renamed column name. All right. We've mentioned data quality refactoring types. Some most common ones are these, but again, there's a host of others. Similarly with referential quality, you know, adding foreign key constraints, soft deletes, something I've seen the most of time. The other ones, are quite common as well. However, unfortunately, we don't have time to discuss
If we have time, I'll talk about my favorite one here later on.
Yeah, the cascading delete.
Oh, lovely one.
Yeah.
Testing. So, testing is important. Like any other refactoring, you really want to know that you didn't break it. What do you have to test? If you're unlucky enough to have stored procedures, you probably have to test them. Find a way to exercise them, either through integration harness, via the app, either directly. In some of our cases, we have applications where we actually have a dedicated harness for those. Referential integrity can be tricky to test, especially if you're exercising through an application where somebody decided that deferred constraint validation is cool. Nothing cool about deferred constraint validation. Let me just make it clear, because there's nothing cool of getting a stack trace when you call the commit on the transaction and it says, hey, listen, I tried to insert this thing and it just doesn't go. Well, where doesn't it go? Where did I insert that, right? So if you ever tempted to use deferred constraint validation as a feature of your database, I beg you do not, because it violates the fail fast, fail early principle. Because otherwise you will get an exception right where you violated it, and you'll be able to fix it in minutes, not hours of chasing where this thing is happening. Views have to be tested if you have any. Materialized views have to be destroyed if your database doesn't do it automatically. Default values, if your app relies on them, they can come in handy, and again, another religious debate. There are pros and cons. Data invariants, constraints, very, very good thing to have in my mind in the database, because quite often the databases are not only accessed through the approved apps, but you know, somebody goes directly into the database and writes a piece of data into the, well, we didn't want to talk about that. Somebody writes a piece of data into the column, and then your app can't read it, and it crashes in the most random places, and you go, what the hell just happened? And of course, data migration testing. That one is tricky. As we said, when we do those refactorings, we move a lot of data around on behalf of our customers. Quite often, as you'll hear, we'll do it while the system is live. So making sure that we don't screw that up is extremely important, and we'll show some of the techniques we use. So enough about how, or why, or what. Let's talk about a concrete example. We'll talk about how we have managed to put the process together on one of the apps Martin and I used to work on together until he left us and moved to Poland. Much warmer climate out there, you know. And we do this at scale. So the app itself has about 6,500 tenants. Martin and I joined Oracle through an acquisition of a company called Taleo. We were one of the largest software as a service companies in the world. So this application has about 6,000 tenants, multi-tenant SaaS app. Does something like 76 million transactions a week. Not the biggest app in the world. Average response time, 170 milliseconds at the server side. We're peaking at transaction loads of maybe something like 20,000 transactions per minute. Average transaction volume is 5 to 7,000 a minute, which is important because we actually do those refactorings that we talked about live when the app is running. We don't do this, hey guys, dear 6,000 customers, tomorrow between the hours of 7 p.m. and 11 p.m., we will be shutting the shop down and see you when we're up. We can't afford it. We're a multinational company with customers throughout the globe. So we actually do a lot of our refactoring while the app is in full production under load. And that's extremely important. Actually, we'll talk about it. Knowing how to do that under load, if anything, actually, you think it increases the stress. It actually reduces the stress quite dramatically. The release models, traditional release model for a SaaS application, single code base. We favor configuration, metadata-driven configuration over customization. So the code base, we can understand what the body of knowledge we have to deal with. Releases do roll every 8 to 10 weeks. You know, we can argue about whether continuous delivery is good or not. For this particular business, we decided that that's not what we need.
Can I just say one thing about this? He mentioned 6,000 customers. That's 6,000 customers on single code base that get all your changes, all your refactorings and everything in that 15 minutes or so.
Which is kind of cool.
Which is kind of cool, but it's also kind of scary, because if you screwed something up and you get customers all over the globe, you're going to hear about it in a matter of 5 minutes.
Oh, our support team loves it when we do something bad because they get inundated with calls immediately. So yeah, no, the beauty of this type of multi-tenancy, yes, every customer has the same code, easier to maintain, everybody has the same features, but everybody gets the same bugs. So, no rollback past the defined point of no return. Who here believes they have a well-defined working rollback strategy for their releases? Pragmatic bunch. At least nobody raised their hand this time. We've been to talks. So, we don't believe that either, all right? Rollbacks are very, very expensive. And in our case, we have determined that at a certain point in our release time, and we'll get into the details, we can't roll back. Over the last 6 years that this app, I've been with this app, we had to execute a mini rollback for like 10 minutes once. I think maybe twice. Once. Right? So rollbacks are expensive to think about, expensive to prep, and we'll show you the mitigation techniques that we use to make sure that we don't need to think about them. As I said, releases are done under average transactional load, and every release has about 70 to 200 database changes applied across 6,000 tenants. So 500,000 changes easy overnight. As I mentioned before, we have two types of artifacts. We do manage them in centralized source control together with the code base. That's extremely important. When you try to refactor something, having a full 360 view on what's going on is important. It's the OR stuff, it's the DDL and DML, it's the store procs, all the data migration scripts, everything is in one place, everything gets merged and branched together. And we separate the scripts into kind of two logical types. DDL, data definition language, and DML, and we'll explain why later, because we have some automation tools that apply them to our databases across the chain of development, QA, staging, pre-prod production in an automated fashion reliably, and we kind of split them and watch them separately.
And we split them into small incremental changes. And here's how we do it. Each one of our scripts has a certain naming convention. It starts off with a file sequence. The refactorings are applied in a sequence. We use the file sequence number for that. We have an automation tool that actually relies on this and picks it up. Each file has a release number. This is basically for our sanity. If taken out of context, sent via email, God forbid, we know which release this came from. Oh, I have built on this. Each file name also contains a project name, so that, again, when taken out of context, we know which project it belongs to. We have multiple teams working on multiple projects at the same time. And a brief description. We'd like to know, by looking at the file name in a stack of 100 files, what this particular file does. As an example, this would say renaming a column in table blah, right? And then there is a suffix, DDL or DML, which again is used both for our sanity as well for our automation tools that apply this to various environments, dev, QA, production, staging, and so forth. Here's a screenshot from our repository. And an interesting thing to notice here is that we do space the files by 10. So basically why we do it is because if we realize that between script number 110 and 120 there's some other operation that we need to do that relies on the, it actually needs to happen between these two, we have 9 opportunities to do this. One important thing that we should mention is that it takes an act of God in our release environment or production environment to actually remove or change the SQL script once you've committed it into repository. The reason for that is that once you committed it, it can potentially be run on a number of environments by the automation tools, which means that once you remove it, we don't know what's going to happen. We want to have a repeatable process everywhere. So if you screwed something up, you added a column that you don't want, well, then it's a simple thing that you write the same script, another script that does fix what you just broke. That's one very important thing about the scripts. The second one is that all the scripts that we write have to be safely rerunnable. That is, you can run the same script over and over and over and over on the same database, and the state of the database will remain the same. I think in our experience, we've never run out of 10 spaces. We came close once. We had, I think, 8 scripts in between doing things, but never had to change the numbering. Another thing that we do is we provide the developers script templates. We'll talk about this a little bit more. For now, it's enough to say that each of these scripts contains an author, project, and a description. This is very useful for code reviews or SQL reviews that we perform. And the description here is meant to be a lot more verbose. It'll tell you exactly why am I doing this, what part of the project, yada, yada. It's not an essay, but it's maybe a sentence or two. I've mentioned that we make the scripts rerunnable. If you can. There's hardly any time that you cannot. And we do it, we have basically 2 methods of doing this. You either look into and I apologize for the folks at the back if you cannot read it.
Couple examples of, and we have templatized examples for how to make your typical script rerunnable.
Right. Basically, we use the run script table, which stores all the scripts, information about all the scripts that were run on this particular database. Or we look into a particular table, and if you're dropping a column, you can first check if that column is there. If it's not there, then obviously you're not going to drop. But if it's there, you can drop, and you can keep rerunning that script. Again, apologize for the font if it's too small, but basically this is our run script table. Each schema has this table, and the automation tools that we use log certain information about each script that gets applied to each of the environments. And this is in dev, QA, and production. So by looking at this table, we immediately know what scripts have been applied to this particular schema. The information we store here may vary, but we even know who applied it, so we can blame people. Anything? Right, common DML patterns that we came across, things to do or not to do. It's very important to avoid bulk updates. You don't want to update 5 million rows of a table. There's ways of doing this with periodic commits and cursors. So if you're expecting a big update, try going for this method. Create and use library of reusable templates for common tasks. Basically, we've noticed that a lot of the stuff that we do is, it's repetitious. We're doing certain things, right? You can introduce templates that will be very helpful for new developers coming on board, or even the old developers who are lazy and don't like SQL, like myself. Or another benefit is when you're reviewing it, if you're working off of a template, you pretty much know where to look and where the changes should be. Back up the data you alter into a table with standard naming convention. This is something that was a painful experience, but we
learned the hard way. But basically, every time you manipulate any data in our process, we ask the developer to write a little script that dumps whatever data you change into a separate backup table. We keep it for a few weeks after the release in case we need to do something, because again, the system is running, right? Data is changing, and they have saved our bacon at least more than once or twice.
Quite a few times. And these get dropped automatically with the next release or 3 releases down the road, depending on the sensitivity of the data and how much we want to keep this stuff around. And last but not least, that's hardly a common DML pattern, but it fits here. Make a friend of your DBA, right? I mean, we've seen scripts that on the face of it should run for 10 seconds, run for 10 minutes on a larger database. And we've seen people, DBAs, looking at that script saying, this little change, right? And then it runs smooth. So make a friend of your DBA, it'll help you. Okay, Leonid has mentioned that we keep everything in source control. This is how we organize it. We have a folder for releases. This would be a release name. 10 minutes left. Then we have a component name. Components are, in our case, various applications that run are as part of the bigger application. And within each component, we have 3 folders that we use to put SQL in: pre, main, and post. Here's what goes where. In pre, we put all the scripts that are backwards compatible with the existing code, or compatible with the existing running code. So, for example, adding a new nullable column is okay, because even if you're doing an insert, it's a nullable column, everything is gonna work. So anything that you can run with your old version of the code. Main is a minimal set of changes that have to be, that break the backwards compatibility, basically. Those have to be applied when the application is down, right? And that's all I have to say about it. Then we have a post folder in which we put scripts and changes that are compatible only with the new code. So you would apply those only when the new code is rolled out. And an example is, you know, not nullable constraints, any other constraints. Oftentimes we use this mechanism for seeding some data, metadata that drives forms or other parts of the application. And you actually have to design a little bit for this to be able to put a lot of stuff in post if you want to, but it's a very convenient method that Leonid will touch up on a little bit later. Here's a snapshot of the repository. As you can see, an example of what I was talking about, this particular script, 106, is reverting what 100 did and 105 did. So somebody screwed up and they had to write a incremental script to fix their mistakes. One other important thing that we do, and I encourage you to introduce that, and you probably do it already for the source code, we do SQL reviews. So basically every data change that gets applied to 6,000 databases gets reviewed by multiple senior engineers, multiple times, often too. And we do it by amassing enough kind of scripts to have some meaningful meeting to go through them, and we do it throughout the release. Every 2 or 3 weeks, depending on the release, we meet and review the code until the code frees. Review the SQL, rather, sorry. And because we store stuff in repository, we get to use our favorite tools, like in our case, it's Crucible, but whatever else you like, you can use for reviews.
All right, we only have 100 slides left, so we should pick it up. Development environments. What environments do we have to apply this process? So you need to have your dev environments. You need to have your QA environments, infrequent pushes, and then you have production environments. All of those are updated using our automation tools. Dev environments get updated the moment the code gets committed, so everybody is on the same version. QA stuff gets committed when we push to QA. How do we do that? We apply the pre-main and post as committed, which means we actually sometimes apply that out of sequence on dev and QA, right? Because Martin committed his change, pre-main post, rolled it out. I committed mine later on, rolled it out, right? So stuff can go out of sequence in our process. On production, obviously, it goes in order. So if you think about it, typical workflow is create the change, release the dev and QA, review the SQL, final integration test, right? And we'll talk a bit about that. Release to production, and then the post-release cleanup. We need the final integration test because as I said, those changes can be pushed to QA out of order, so 020 post got processed before 210 pre, and that's not how we're going to run them on production. So what we do in our environment...
And that's because different people wrote it at different times.
Right. We will run the pre on a dedicated QA environment, and then we'll execute a regression test to make sure the old version of the apps can still run as expected. Because we expect to run this stuff while stuff is running in production. Then we'll run the main, deploy the new version of the code without the post. Guess what? Do another regression test, make sure everything still works without post. Then we run post and do it again. Right? This guarantees that when we go to the release stage in production, everything as expected. Now, on the day of the release, we will run the pre. Quite often, the pre may start, if the release is Thursday night, which is a typical launch window, we may start pre on Tuesday because it's safe. We don't care that it runs under normal load. It may take hours, days. We know and we can measure it. So we run it while the app is running. Then we shut down the app and run the main. Then deploy the new version of the app, then run the post while the app is running, and only after post is completed, some of the new features of the application may become available to our customers. Now, you're probably wondering, you guys were talking about this whole zero downtime thing, right? What's up with this main thing, right? Because when the main is running, the app has to be down. It makes the schema backward incompatible. Well, over the years, and That took some time because developers don't like writing SQL, and the SQL you end up writing is a bit more complex. We learn how to do those releases without any main. So basically in our process today, we have the pre and the post. And no changes require the application to be down. And the amount of stress on those release nights have gone down tremendously for us.
We do them from home in 15 minutes.
It used to be like a war room every 8 to 10 weeks. Now it's like, whatever, there's a release going on, who cares? And they're pretty big, right? And a large release, we will make several hundred changes across 6,000 databases. Click of a button, right? So getting to that SQL took years, several years, 2 or 3 years probably, to develop the template library that allows to take a change that would normally go into main, would be rather small, that can go into pre and then post.
And all the patterns that, am I on? Yeah. And all the patterns in the book are actually very, very helpful in going for eradicating the main, right? Yes, you're going to have to write 3 scripts or 2 scripts instead of 1 sometimes, but there's value to it, so we do it.
So here's the stuff we typically see fail, right? And that stuff does fail. Now, the good news for us, since we don't have any main anymore, when it fails, well, we don't really care. Everything is rerunnable.
It fails on pre or post, so who cares?
Customers can keep using the app, so we can calmly, emphasis on calmly, troubleshoot the issue and go figure it out and then go fix it. Everything is rerunnable, by the way, so we don't even try to figure out what went wrong. We just go take that stuff and rerun it again.
All right. So what we've learned is that it's extremely valuable to document your schema changes process. Yeah, documentation sucks. The best thing to do is, making it sucks. Using it, a good one is nice. Wiki page where you have the entire flow described. Very good for onboarding new people. Also very good for you to review it occasionally and see where improvement points are possible. Managing database, artifacts and source control. We've beat that one to death. I think it's enough said. Have your own version of SQL policeman. I like this. I don't like SQL, but in my team there was a guy who loved SQL, and we empowered him to run those SQL reviews.
And he has attention to detail. Like he'll spot a comma out of place.
In 200,
Is that good?
200 lines of SQL. Well, we don't have 200 lines of SQL in one file, but should we have? So if you find someone like that in your organization, empower them. Have them run the SQL process review for you. Developing reusable templates is fantastic. Cuts down on development time, error, and onboarding of people as well. Repeatable automated process to apply changes to all environments is essential. You want to make sure that stuff eventually gets run in the same order everywhere, because if it doesn't, you don't really know what you've run with SQL.
And all this bullshit, I just checked out the code from source control and connected to the dev database, and something doesn't work because I'm missing a table. Gone.
And last but not least, make a friend of your DBA.
Oh, no, I'm serious, right? It's easy to joke about the divide and the cultural divide between us as the development community and the database administration teams. But a skilled DBA has made our life so much easier so many times. And ultimately, they're responsible for making sure that the databases are up and running. They don't run out of any useful resources. So collaborating with them is much better situation than having an adversarial relationship.
And if you're in a comfortable situation where your organization allows or makes time for your DBAs to work in sprints and tasks, that's the best thing you can do because you get an early feedback and early help on SQL.
So, some key messages. Guys, this stuff is hard. It's hard because there are no tools. It's hard because developers hate SQL. It's hard because there's a divide between the development community and the database community. Automating everything gets you repeatability. Like what you do with the code is extremely essential to the success. Reviewing everything. It's very easy for us to find a bug, fix it, and roll the new code to production. It's a simple war file deploy, we're done. If you screwed up your database refactoring and in process lost customer data while the system was running, well, good luck with that. So review everything. We have 100%, if not 150% review coverage on our SQL changes. Obviously, backing up crucial data, because you will eventually screw up. We do still. And test as much as you can reasonably can, right? Don't reinvent the wheel. The patterns are well documented. There's a book. There's an agile data website. There's a movement. There are tools. You don't have to be the first one, and it helps to just rely on other people's experiences.
There's also a fantastic podcast that I discovered the other day by the author of this book, and actually Martin Fowler. It's not referenced here, but I'll happily send out the URL to whoever asks.
So we probably have time for a few questions, and if Jacob is around, he can probably start setting up. So any questions?
Just one. We've got 2 minutes.
All right. Jacob can be nice and, you know,
Give us 3 more minutes.
he's standing between you and lunch, so yes.
Okay, I have a quick question, so we'll see how long the answer will be. I have a question about testing the data migration. Let's consider changing the column name, right, as we previously considered. And we move data from one column to another. And what about the tests? These 2 columns should be available for some period of time for testing, or should we do it somehow else?
No, you have to maintain both information, schema information semantics, right? The old schema has still to be supported. So you need to make sure that you don't break that, especially if your transition period is long. In our cases, the transitional periods can be as short as few weeks, but we had transition periods that are as long as a year, right? So you have to test both scenarios because both of them are still needed for production. So no, you have to make sure you have tests for both. So short answer. Hopefully expected. Any other questions? Going once?
Shameless plug then.
Oh yeah, shameless plug. Oracle, we're in town, we're hiring. There's another gentleman here sitting in the front row. One of our architects is doing a talk on agile roadmap management. Pretty cool stuff. That's how he manages me as one of his stakeholders, and he'll tell you all about it. And I'm not the easy guy to manage, right, Pablo? CS, I'm doing another talk tomorrow on mobile security. Top 10 of us, top 10 for mobile. So if you're interested in that subject, mobile is pretty cool nowadays, and it's everywhere. So come see me tomorrow. And with that, thank you very much.
One more thing on the hiring front. Not only full-time, I'm also looking for contractors. I'm looking for interns. I'm looking for UI folks who don't know Java but know JavaScript. Looking for Java folks. And thank you very much.
I think, is going to start charging us by the word here for advertising. All right, guys. Thank you very much for your time.
Thank you very much.
Cheers.